Hi guys, here are the last 3 questions about kind of clarifying your understanding about the position, velocity, acceleration word problems. And there's kind of 3 things that have come up in some of the questions that people have asked. So the first one is when the object changes direction. So remember, the thing that tells us the direction of the object is the velocity, the sign of the velocity, whether it's positive or negative. So if velocity is greater than 0, the direction is going to the right. And if velocity is less than 0, the direction is going to the left. So to analyze when that would happen, when that sign change would happen, obviously that's going to happen at the zeros of your velocity function. I would think in almost any situation, if you have something moving to the right and changing direction, moving to the left, it has to come to a stop in between those 2 times. So I'm going to just kind of make up a velocity function. V at t equals t squared minus 7t plus 10. So we know that the velocity function will change or could change direction when you have a velocity of 0. So we need to check where that would happen, and I will factor to get the zeros of this. And we have 0 velocity at t equals 2 and t equals 5. So we're going to look at, and this seems a little bit overkill for a velocity function that's a quadratic, but I like to set it up this way because it's going to come in handy later in this unit and in the next unit for sure. So I'm going to set this up in intervals. So everything before 2 on a number line, and then everything between 2 and 5, and then after 5. And because we're dealing with time specifically, that's going to start at 0. We're not going to include any negative values here. If you guys were in my class for advanced functions, then you probably remember this when we were analyzing the sign of a function, where it was positive and negative. So I'm going to analyze what the velocity would be at each of these points, whether it's positive or negative. So here, I'm going to think about numbers between 0 and 2. That would, if you plug those numbers in, say like a 1, we would end up with a positive value for velocity. If you sub in a number between 2 and 5, so you can do a check with 3 or 4, for instance, you're going to get a negative velocity, and a number bigger than 5 will be positive again. So you want to look for a sign change here. That tells you that the object changes direction. So for instance, it has a positive velocity until 2 seconds, and then between 2 and 5 it has a negative. So that change in sign tells you that you had a change in direction. So changes direction at t equals 2 and t equals 5 here. But you do have to kind of analyze the signs because that might not always be the case. For instance, if I had a different velocity function, what if I had v equals t squared minus 10t plus 25? So when I factored that and found the zeros, I would have that. So the velocity is 0 at t equals 5. But if you check this same thing, going from 0 to 5 seconds and then 5 seconds for forever, the velocity is actually going to be positive in each of those because it's a factor is squared. So there's no sign change here. That means that there's no direction change. Okay, so that is that is a case where this table, where the kind of the analysis of what's happening at those zeros, you can't necessarily just find the zeros and say that has to be where it changes direction, because it doesn't always. This comes to a velocity of 0 at t equals 5, but then it continues on in a positive direction. So there's no direction change there. That's why you have to look in the table for at that kind of dividing point, does it change from a positive to negative or negative to positive? So the next thing talks about when is the velocity at a maximum. So when the velocity is at a maximum would be when the acceleration equals 0. So if you were increasing velocity, and we'll kind of just look at in the positive direction, if you have your velocity and you're accelerating in the positive direction, and you get to some maximum velocity, if you start to slow back down, that means your acceleration has changed to a negative. So that what we're looking for is the points in time where the acceleration is moving in a positive direction, but then starts to move in a negative direction to slow you back down. So a case like this might be if we had, let's say, a velocity function. You know what, we'll maybe just do this here from above. If you had the velocity function t squared minus 7t plus 10, we can find our acceleration function there, and that's 2t minus 7. And now we want to look at where the acceleration equals 0. So that would be at t equals 3.5. So we again need to analyze this table. Did the velocity here change, or the acceleration, pardon me, change from positive to negative? So 2t minus 7, we're looking at the acceleration, and we want to look at time before 3.5. And then from 3.5 on to infinity. So the acceleration, and we are going to have to kind of analyze this with up here, and this is probably going to actually give us a big negative velocity. So when is our velocity actually? This one's going to end up being a minimum, but it works the same way. Here we want to check the sign. So we see between 0 and 3.5, the acceleration is negative, and after 3.5, the acceleration function will give us a positive value. So we know that at this 3.5, we have a negative velocity from analyzing in our velocity up there. It would have a minimum velocity at t equals 3.5, and you could figure out what that minimum velocity was by subbing it into the velocity function. So here we know the velocity is negative, the acceleration is negative, which remember is from the last video is actually increasing the speed, so it's making it go faster in the negative direction, but then the acceleration turns to positive and starts to slow down the speed because again our velocity is negative. So this goes from over here from 2 to 3.5. It has a negative velocity, negative acceleration. That's where it's like speeding up in the negative direction. And then after 3.5, it's still in the negative velocity section, but now you've gone to a positive acceleration. So that's slowing down because those signs are opposite. The last thing is looking at when the distance is a maximum. So that's really kind of ties back to the first one, when the object changes direction. That's as far away from the original point as you could get. So you look at where it changes direction. So just like in A, and you're going to check those values. And I didn't have a displacement function here. I just kind of started with the velocity. So you'll check all of the different values where for displacement or position, where those times are that involve a change in direction. And I hope that makes sense. Please give me an email if you need any more help with that.